In the chemistry lab, we will often need to convert between temperature units. You're probably already familiar with the Fahrenheit scale if you live in the United States, and you may be a little familiar with the Celsius scale, but there's also a third temperature scale, the Kelvin scale. In the chemistry lab, Celsius is generally used, and in calculations, Kelvin is generally used. The Celsius scale is based on the freezing and boiling points of water. The freezing point of water is 0 degrees on the Celsius scale. The boiling point of water is 100 on the Celsius scale. The Kelvin scale is based on the lowest possible temperature for all substances, which is called absolute zero. Since it is an absolute scale, we do not use a degree symbol in front of the K for Kelvin. We do use a degree symbol in front of the symbols for Celsius and Fahrenheit. The conversion we use to go between Celsius and Kelvin is Kelvin equals degrees Celsius plus 273.15. Because the Celsius and Kelvin scales are related by a simple addition or subtraction, the size of the degree in Celsius and Kelvin is the same. The only difference is that they have different starting points. The freezing point of water is 0 on the Celsius scale and 273.15 on the Kelvin scale. The difference between the boiling and freezing points of water on the Celsius scale is 100 minus 0, which equals 100. The difference between the boiling and freezing points of water on the Kelvin scale is 373.15 minus 273.15, which equals 100. It is the same number of degrees for both scales. In our first example, we are converting from Celsius to Kelvin. We use our equation as written and plug in our known degrees Celsius where it says degrees Celsius in the equation. 28 plus 273.15 gives us 301.15 Kelvin. In our second example, we are converting from Kelvin to Celsius. To do this, we will need to rearrange our equation to get Celsius by itself. We subtract 273.15 from both sides and come out with Kelvin minus 273.15 equals degrees Celsius. We plug in our kelvins into our equation where it says K and get 215 minus 273.15 equals negative 58.15 degrees Celsius. Normal body temperature is 37 degrees Celsius. What is this in Kelvin? Is it A, negative 310 Kelvin, B, negative 236 Kelvin, C, 236 Kelvin, or D, 310 Kelvin? For this problem, we're going to use our equation that the degrees Celsius plus 273.15 equals the number of kelvins. So we take our 37 degrees Celsius, add 273.15, and we get 310.15 Kelvin. And notice that we're using the addition rule for our sig figs, so it goes by digits after the decimal. Since the 37 did not have any digits after the decimal, we do not have any digits after the decimal in our answer. So the answer is D, 310 Kelvin. As you're doing your temperature conversions, the Kelvin temperature should always be a larger number than the Celsius temperature because the Kelvin scale starts out lower. The Fahrenheit scale is based on your everyday experiences. 0 degrees Fahrenheit is the coldest you are likely to experience going outside in winter, and 100 degrees Fahrenheit is the warmest you are likely to experience going outside in summer. There are temperatures above 100 and below 0 in certain locations, but the scale was invented at a place and time in which this was the typical range. Using the Fahrenheit scale, the freezing point of water is 32 degrees, and the boiling point of water is 212 degrees. 212 minus 32 is 180, which means on the Fahrenheit scale there are 180 degrees between the boiling and freezing points of water. This is different from the Celsius and Kelvin scales, which have 100 degrees between the boiling and freezing of water. This makes the size of the degree on the Fahrenheit scale smaller than the size of the degree on the Celsius or Kelvin scales. More of those smaller degrees are needed to reach the boiling point of water. The conversion between Celsius and Fahrenheit accounts for the different size of the degree by multiplying by 1.8 degrees Fahrenheit over 1 degree Celsius, which is the same ratio as 180 degrees Fahrenheit over 100 degrees Celsius. Another way that you might see that ratio expressed is 9/5, but it's still that same 180 over 100 ratio. The conversion between Celsius and Fahrenheit also has to account for the different starting positions of the scales. The freezing point of water on the Fahrenheit scale is 32, but the freezing point of water on the Celsius scale is 0. It accounts for this difference in starting values with the plus 32 degrees Fahrenheit at the end of the formula. This figure shows a comparison between the Celsius and Fahrenheit scales. The Celsius degrees are larger, and only 100 are needed to get from freezing to boiling of water. The Fahrenheit degrees are smaller, and 180 are needed to get from freezing to boiling of water. In our first example, we are converting between Celsius and Fahrenheit. When we want to solve for Fahrenheit, we use our equation as is. We plug in our 28 degrees Celsius in where the equation says temp in degrees Celsius. We do whatever is in the parentheses first, so we have 1.8 times 28, which gives us 50.4. After multiplying them together, we add 32 and come out with 82 degrees Fahrenheit. In our second example, we are converting from Fahrenheit to Celsius. To do this, we need to rearrange our equation to get Celsius by itself. First, we subtract 32 degrees Fahrenheit. Then we divide the whole thing by 1.8 over 1. In other words, we multiply the whole thing by 1 over 1.8. We need to be really careful about our parentheses as we rearrange our equation. Once we have our rearranged equation, we plug in 215 degrees Fahrenheit where it says temp in degrees Fahrenheit. We do the 215 minus the 32 first and come out with 183. Then we divide by 1.8 and come out with 102 degrees Celsius. Convert 30.0 degrees Celsius to degrees Fahrenheit. Is it A, negative 1.11 degrees Fahrenheit, B, 86.0 degrees Fahrenheit, C, negative 15.3 degrees Fahrenheit, or D, 112 degrees Fahrenheit? For this problem, we're going from Celsius to Fahrenheit, so we can use our equation as is, 1.8 degrees Fahrenheit over 1 degree Celsius times our temperature in Celsius that's given in the problem. Then we add 32 degrees Fahrenheit, and that will give us our temperature in Fahrenheit. So we're going to plug in our number, 1.8 degrees Fahrenheit over 1 degree Celsius. And here's where we plug in our 30.0 degrees Celsius. And then we're going to add our 32 to get our temperature in Fahrenheit. Now we need to do the part in the parentheses first. So for this particular version of the equation, we're doing the multiplication step first and then the addition. So we do 1.8 times 30, and that gives us 54.0 degrees Celsius. Then we will add our 32, and we come out with 86.0 degrees Fahrenheit, which is B. For sig figs, the 1.8 and the 1 are exact values. That relationship between Fahrenheit degree and the Celsius degree is exact. And the 32 is exact also. So the value that we get for our degrees Fahrenheit will have the same number of sig figs as our starting value in degrees Celsius. So since we had 3 sig figs in our starting value, we have 3 sig figs in our ending value. You can double check a few things to make sure that you set up your equation correctly. One of those things you can check is units. Notice that there's degrees Celsius in the denominator, and then it's being multiplied by degrees Celsius in the numerator. So the degrees Celsius cancel out, and you're left with degrees Fahrenheit. Once you have degrees Fahrenheit from this multiplication step, we're adding degrees Fahrenheit, and then we end up with degrees Fahrenheit in our answer. So we want to make sure those units stay consistent. So Fahrenheit plus Fahrenheit equals Fahrenheit. When you are done double checking your units, you can also think to yourself about the relationship between the size of the degree and the starting point on the scale. So remember, there are 180 degrees Fahrenheit going from the freezing to the boiling point of water, compared to 100 degrees Celsius going from the freezing to boiling point of water. So that number for the degrees Fahrenheit is going to be larger, and the number for the degrees Celsius is going to be smaller. Also remember that for the freezing point of water, it's 0 on the Celsius scale, but 32 on the Fahrenheit scale. So we're adding 32 to go from Celsius to Fahrenheit. So once you've double checked those relationships and double checked your units, then you can be pretty certain that you've used the correct equation. Here is a summary of your temperature conversion equations. You don't necessarily need to memorize all 4. You can memorize the one which converts from Celsius to Fahrenheit and rearrange the equation yourself to get the one that converts the other way. You can memorize the one which converts from Celsius to Kelvin and rearrange the equation yourself to get the one that converts the other way. Just be careful as you do it to pay attention to the parentheses. We do the multiplication first when converting from Celsius to Fahrenheit, but we do the subtraction first when converting from Fahrenheit to Celsius. To solve some problems, you don't necessarily need to do a temperature conversion calculation, as long as you know some common temperatures on each scale. You should know that the melting temperature of water is 32 degrees Fahrenheit, 0 degrees Celsius, and 273.15 Kelvin. You should know that room temperature is 70 degrees Fahrenheit, 25 degrees Celsius, and 298.15 Kelvin. Body temperature is 98.6 degrees Fahrenheit, 37 degrees Celsius, and 310.15 Kelvin. The boiling point of water is 212 degrees Fahrenheit, 100 degrees Celsius, and 373.15 Kelvin. If I were to give you a temperature like 31 degrees Celsius, you would know it is somewhere between room temperature and body temperature. So you would know it is somewhere between 70 and 98.6 Fahrenheit.